file system management algorithm and disk scheduling algorithm. File system management algorithm 1. Linked allocation with file allocation table, FAT, MS-DOS environments. 2. Indexed allocation with 3 levels of indirection, Unix systems. File allocation table. Linked allocation with file allocation table. The system maintains a table with as many entries as blocks has the system. File allocation table, FAT. For each object, only a reference to its first block is kept. These references are in the folder that contains the object. In the table, each block has a reference to the next block, so they can go along chaining blocks of a file from first to last. The FAT table size equals disk size, block size. Blocks required for each file equals file size, block size. For simplicity in the simulation, the folders occupy only a block, and the links none points to an existing item, and that information is only kept in the directory that contains the link. Indexed allocation with 3 levels of indirection. Indexed allocation is based on a structure called the inode, and each object is associated with an inode. The structure of an inode is information fields, 12 pointers to data blocks, 1 pointer to one indirect block, 1 pointer to one double indirect block, 1 pointer to one triple indirect block. The single indirect block points to data blocks. Double indirect block point to blocks which in turn point to data blocks, and triple indirect blocks point to blocks that point to block that point to data blocks. To create new files, first inode data blocks are used, then the single indirect, double and triple blocks to fill the information required depending on the file size. For simplicity, folders occupy a block of data and links none. Disk scheduling algorithm 1. First in first out, FIFO. 2. Last in first out, LIFO. 3. Shortest seek time first, SSTF. 4. Elevator scan. 5. Circular scan, C-scan. 6. Look. 7. C-look. FIFO. First in first out. This scheduling is quite simple. Serves requests in strict order of arrival. The head moves always looking for the next request wherever it is. Do not try to minimize head movement, but it's correct because it does not prioritize any request. Here is example with Q 95, 180, 34, 119, 11, 123, 62, 64. LIFO, last in first out. Unlike FIFO, serves requests in the reverse order of arrival. The last came first served. The latest requests are served immediately, but may cause starvation. The first requests will never be served if new ones are arriving constantly. Hear this example with Q 95, 180, 34, 119, 11, 123, 62, 64. STF, shortest, seek, first time, always serves first closest request to head's position. Such scheduling minimizes head movement, but can also cause starvation. Hear this example with Q 95, 180, 34, 119, 11, 123, 62, 64. Scan, also called elevator, head moves from the outermost cylinder to the innermost. When it reaches the end, it changes direction and returns to the beginning, and so on indefinitely. Handle requests when they turn up during its movement. Hear this example with Q 95, 180, 34, 119, 11, 123, 62, 64. C-scan, circular scan, same as scan. The difference is that when it reaches the inner cylinder at the disc ends, it moves directly to the beginning and starts again. So always handle requests in the same direction. Improving one of the scan drawbacks, which goes over track that have just been seen when it changes direction. Hear this example with Q 95, 180, 34, 119, 11, 123, 62, 64. Look is a variation that improves scan scheduling. The difference is that it only goes up to the last request and not until the last cylinder. At the moment it detects that there are no more requests forward, then it changes direction. Hear this example with Q 95, 180, 34, 119, 11, 123, 62, 64. C-look, circular look, includes both look and C-scan. Improvements only go up to the last request, and also when it reaches the outer, moves to the first one and starts again. It always serves requests in the same direction. Hear this example with Q 95, 180, 34, 119, 11, 123, 62, 64.